So to start, we're going to consider our rabbits problem from the previous lesson. So this is one you solved for me already, and I just reproduced the work you would have done to solve this here. So this is our function that models the number of rabbits. Population growth is a really common use of exponential functions, by the way. And notice we got a y equals ab to the x type of function. And the reason this is easy, the first reason is obviously, like, I got the a from the table here, right? So the first reason is just like my a is given in the table. And then the second reason, and this is probably less obvious to you because we really only considered this type of function, is that my increment for my years is counting by ones, right? So each row in the table gives me just a change of 1 year. The reason that that is helpful is my b becomes easier to find. So what do we want to say here? So that my years increase by 1 at a time. Okay. So here, obviously, our R3's problem. R3's are not commonly modeled by exponential equations, but here we're going to use an exponential to model these. This automatically then is harder because we're counting by 2's, right? Our days are going up by 2, so we're not tracking R3's every day. Our a is still given in the table, right? So we have a equals 320. It asks us to call it a of t, but I'm going to use y for now because we might do a little bit of algebra with this. So we're going to be like y equals 320 b to the t power, right? As we just plug in a point. So here's my y, here's my t, right? And I'm going to be like, okay, 226 equals 320 b squared, right? And I want to isolate b, so I'm going to divide by 320 on both sides. And then I'm going to square root both sides. So I'm going to say the square root of 226 over 320 is equal to b. And by convention, we use the positive square root, and this is a number I can get from my calculator. By the way, we're going to be using this calculator a lot this lesson, so I'd say make sure you have it in hand and are following along at home. So what I would do here is I'd do alpha y equals, we'll do the square root first, so just kidding. We're going to do the square root, so second square root, and then put a fraction underneath the square root, y equals, and then I'm doing the square root of 226 over 320, and there's my b value. And I'm going to keep lots of decimal places because when you round, these get inaccurate very quickly. So I'm going to say 0.8404. Okay, so that was my b value, and now I can write my a of t. So let's say a of t equals 320 times 0.8404 b power, and that would be my relationship between the number of R3's and number of students without R3's, I think it's supposed to be, and the days here. Okay. Now, notice I picked 2 and 226. There's this other point here, right? And both points are on the curve, so it shouldn't matter which one I pick. So I'm going to do this a different way here over here. I'm going to be like, okay, I still am using the same equation, but I'm going to use my other point. But here I get b to the 4th. So to address that, we are going to use this rule down at the bottom. So this rule says that a root really just represents a fractional exponent. So a more concrete example of this rule would be, I don't know, the third root of x is equal to x to the 1 over 3. The 12th root of x is equal to the x to the 1 over 12. And you can obviously write your own example, pick any number for n, and this relationship holds. So that means instead of doing the 4th root, I can use the 1/4 power as my inverse operation, right? Oh, by the way, if I just have the square root of x, this is a very good one to write down. That's x to the 1/2 power. We actually use that identity a lot in calculus next year. All right, so what that means, right, is I want to do for my b here to the 1/4 power on both sides. And again, the reason I'm trying to isolate b, and like it's very clear that my b will be isolated here because we already know that the rule here, power to a power, we multiply. So 4 times 1/4, my 4's cancel out, and I just am left with b to the 1st power on the right, and you don't need to write that obviously. And then on the left, I'm going to use my calculator. So I did alpha y equals I'm going to type in my fraction, and then I'm going to do the caret, and then alpha y equals to do another fraction, and I'm going to do to the 1/4 power. Notice I get pretty much the same number. It's a little bit different because I rounded the values when I made the table, because we're talking about students, and I didn't want to cut a student in half. But it gets basically the same result, and I wouldn't mark you wrong on a test for this difference, right? So it's roughly the same thing. So 0.84 is you get. So same thing. These are equivalent. So it doesn't matter what point I use, which makes a lot of sense. And the fact that the table, specifically the time in the table, is counting by twos is why this problem is more challenging. All right, the last thing we're going to do is consider what is probably the most challenging part of your delta math. So I'm going to give you a full-on example this time because these are pretty tricky. So it gives you an exponential function, and we have 2 points on the exponential function. And I find it very helpful to rewrite these as points, 2, 14, and 3.5. Oh, this one's already ugly. 3.5, 27. And I'm asked to find f of 7. I'm just going to highlight that for now. It's going to be a long time before we can get there. And I know it's an exponential function, so that tells me to use y equals ab to the x. And I'm going to write 2 equations, actually. So I have 2 points. I don't have an a value, so our method from the previous page is not going to work. I'm going to be like 27 is my y value equals ab to the 3.5. And I wrote these. Notice I kind of lined them up really nicely. And that's because if 2 things are equal, if I divide them, the results are still equal, right? So notice when I do that, that's convenient for me because my a's cancel out. I'm left with 27 over 14 equals, the rule here is I subtract these, right? So I'm going to get b, 3.5 minus 2 is to the 1.5, right? So when I divide like bases, I subtract. And then, well, if I'm trying to isolate b, I raise it to the reciprocal power. So it'd be 1 over 1.5 on both sides. So these cancel out, and I'm just left with my b equals 27 over 14 to the 1 over 1. Okay, so I'm typing in my calculator. I don't actually have to use the fraction up on top, by the way. You can just use the division symbol as well. And you're going to always get some ugly decimals. So I'm going to note it. It's 1.55. We're going to save that number on our calculator for later, right? So now I have y equals a to the a times 1.55 to the x. And I'm going to use one of my points. I'm going to use the simpler one with no decimals. So I'm going to get 14 equals a times 1.55 squared. And then a would be 14 divided by 1. And then on my calculator, when I type it in, I'm not going to type in 1.55. I'm going to do 14 divided by, and then I'm going to use second, and then answer squared. And the reason is I don't want to use that rounded version, right? I want to use the whole number because that rounding is going to throw us off quite a bit. So I get a equals 5.83. So then my y would equal 5.83 times 1.55 to the x. Okay, that was a lot, and we're still not done, right? So notice we're actually asked to find f of x. I'm just going to rename my y f of x. We can kind of use those interchangeably in this case. And then f of 7, which was our question, would be 5.83 to the 1.55 to the 7th. But, again, I do not want to round. So on my calculator, I'm going to select that, enter, it copies and pastes it for me. I'm going to put in parentheses, and then I'm going to select my b value, enter, I'm going to put in parentheses, and then I'm going to put to the 7th power. And this is important because exponentials are really sensitive to rounding error. And notice I get a nice number here, 125. So the nearest hundredth just rounds very nicely to 125. Okay, so there is my solution. So definitely follow my steps on the calculator here because that rounding error is going to mess you up otherwise, unless you use that copy and paste feature like I just showed you.